My name is Dave Farina, and I'm a science communicator, probably best known from my YouTube channel, Professor Dave Explains. The laws of thermodynamics. So thermodynamics is the study of energy, essentially, and well, there's four, technically. The first is about energy conservation. Energy cannot be created or destroyed. The second is about entropy and how the entropy of the universe increases for any spontaneous process. And then the third is about absolute zero, the entropy of any substance. It will be zero. It will be a crystalline substance at absolute zero, to the lowest temperature possible. The Zeroth Law is a very fundamental law because we're talking about thermal equilibrium. So when we say thermal equilibrium, we're talking about heat transfer. We know that heat transfers from hot to cold objects. When we're talking about something that's hot, it's just the kinetic energy of the particles is higher than a system of lower temperature, lower kinetic energy particles, and it will impart that kinetic energy onto something else until equilibrium is reached. You have something hot, you have something cold, and then they meet here. So absolute zero is the lowest temperature possible, which at first may seem like a bizarre notion. How can there be a lowest temperature? But again, temperature, what is temperature measuring? Temperature is a measure of the average kinetic energy of the particles in a system, right? So very hot, zipping around really fast, very cold, moving very slowly. So there's a limit there, right? When you have zero kinetic energy, when nothing is moving, that's zero temperature. So entropy is a very elusive concept, and we're talking about the dispersal of matter or energy in a system. One very simple example, going from solid to liquid to gas, you're increasing the entropy because you have a solid lattice where all the particles are in this highly ordered structure, and then if they were to melt so that they're not highly ordered, and then go into the gas phase where they're just distributed, spread out far in a greater volume, that would be an increase in entropy. So the laws of thermodynamics are super important. I mean, energy is the capacity to do work, which is what is involved with the displacement of any object. So anytime you're thinking about anything moving, so really anything happening ever, you're talking about some kind of energy transfer, whether you're seeing an object fall or you're walking from here to there. There's something to talk about with energy exchange and energy transforming from one type of energy to another, kinetic to potential or vice versa, whatever it is. Physics is very much the fundamental science in that regard, as everything breaks down to physics. Biology breaks down to chemistry. Chemistry breaks down to physics. Ultimately, we can talk about chemical reactions, but it doesn't make sense if you're not talking about some kind of energy exchange. If we don't talk about energy, if we don't learn about energy, we then cannot really talk about anything else in a concrete way.